double replacement reactions. This is the fourth type we're talking about. And they're going to be the little bit trickier because we're going to have something called solubility rules that you will have to memorize. You do not get them on the test. You get the activity series. You do not get the solubility rules. So basically, they're like a single replacement, except now two things are switching. Okay, and so the best and easiest way to do it is when we write them, we're going to do outside and inside go together. That's the easiest way to remember it. But basically, the positive ions are switching place with the other positive, but you still have to put positive and negatives together. Okay, so you're going to need solubility rules when we're doing this, which we'll talk about in a minute. And then, of course, you have to make sure you're writing the formulas correctly, which is still some struggles for a few kids. These are the rules for predicting double reactions. I'm not going to read through them. They're there for you to look at. But basically, I'm going to tell you this. If we do a double replacement reaction and we form a solid, liquid, or gas, the reaction takes place. Okay? Because those are pure substances that we're forming. If the reaction only produces aqueous things, meaning they're dissolved in water, then the reaction is a no reaction. Okay, so we will also have some no reactions in this. So this is telling you all this, these rules. You can go back and read them, but I'm just in a nutshell telling you if a solid, liquid, or gas is formed, then the reaction happens. So previously I haven't really cared if you put the states of matter by the product, but for double replacement, you have to, because that's how you're going to check to see if the reaction is taking place or not. So for double replacement, you must write the states of matter. Okay? So let's look at the solubility rules, okay, and the way that they're going to work. The solubility rules, the top half, is telling you what is always soluble, and soluble means it's aqueous. So that, you might want to put aqueous, AQ. So if it's soluble, it means it's aqueous. It means it stays dissolved in the water. Okay? The group 1 metals and ammonium are always soluble. There is no exceptions to that. So if you see one of those things present, you can immediately say it's aqueous. Okay? And that product will not form. Nitrates and acetates, also always soluble. No exceptions. Okay? And then if you look at chlorides, bromides, and iodides, the way this looks is they're always soluble unless they're with silver, mercury, or lead, and then they form an insoluble solid. Okay? Sulfates, same thing, always soluble unless they're with one of those exceptions, and then they form an insoluble solid. Okay? If you look at the bottom half of the list, insoluble compounds means they are not going to stay dissolved, so they form this insoluble solid. So we would write a little S for solid. Not S for soluble, S for solid. Okay? So same thing, all of those listed are insoluble unless they're with one of the exceptions. And what do you notice about the majority of the exceptions? Group 1 metals and ammonium, because those are always soluble. And then some of them, like hydroxides, will list some, sulfides will list some other things, and oxides. Okay? So that's the way we're going to use this list. So what we will be doing is we will write our products, and then we'll go check our solubility rules. Okay? So I'll show you what that looks like. We're going to do quite a few examples today. So the way that we do this is outside, inside. That's the easiest way to do how they go together instead of trying to switch things around. So I usually just draw little lines and say outside, inside. Okay? Doesn't matter which one we write first. So you pick. Do we want to do the inside or the outside here? Outside. So I need to put sodium and oxygen together. I pay no attention to what their subscripts are on the reactant side, and I put them together based on what their charges are in real life. So how would I write sodium and oxygen together in a compound? Na2O. How would I write magnesium and chloride? MgCl2. Now I'm going to go check my solubility rules. Sodium is a group 1 metal. What does it say about group 1 metals? Always soluble, which means we write a AQ. It's aqueous. What does it say about the chlorides? Always soluble unless there was silver, mercury, and lead. Clearly magnesium is not that, so also aqueous. When everything is aqueous, it's a NER, no reaction. Okay? So that would be a no reaction. So we don't need to bother balancing it. If it's a no reaction, why would we balance it? It doesn't happen. So move on if it's a no reaction. Next one, potassium permanganate plus sodium oxalate. Outside, inside. Which do we want to do first this time? Inside. Okay, so I have sodium and I have permanganate. How would I write that when I put them together? Right? Just all 1 and 1 because they're both a +1 and a -1. And how would I write potassium oxalate? K2C2O4. Now we're going to check our solubility rules. Well, what do I notice about both sodium and potassium? They are group 1 metals. Both of those are going to be aqueous. Don't worry, we'll do some that are not. NER, no reaction. Okay? A reaction occurs if I get a precipitate, a gas, or a liquid. Okay? So now let's do some other examples, and they're going to be reacting. Okay? I do these so we can get used to checking the solubility rules. Okay? All right. These are in your packet. It's number 2, 4, and 9. Okay? So number 2, how do I write silver nitrate? Yeah, y'all should probably, oops, sorry, forgot to say I was going to write. Y'all should probably recognize that by now. We've seen it a lot, right? How would I write potassium phosphate? K3PO4. All right, let's outside, inside it. What do you want to do first, outside or inside?
Outside.
Outside. All right, how would I put silver and phosphate together? Ag3PO4. And how do I put potassium and nitrate together? KNO3. So right away, I'm going to look at potassium because it's a group 1 metal, but it also has nitrate, which is also always soluble. So for sure, KNO3 is aqueous because both of those things are always aqueous. It's like extra aqueous. There's no such thing. It's just aqueous. Okay. So what about phosphate? Silver's not listed on there, but phosphate is. Find phosphate and tell me what it says. Insoluble unless it's with one of the exceptions. Silver is not a group 1. It's definitely not ammonia. So it's going to make an insoluble solid. So what do we put behind it? An S. So because I wrote a solid down, this reaction happens. So now I want to go balance it. Okay? Don't balance them unless they happen. It's just a waste of time. But this one happens, so let's balance it. Yes?
When something dissolves in water, does it form a hydrogen bond with the water?
No. It's usually forming an ion to, it depends on what it is. It's usually forming an ion to ion interaction. The only thing that can form a hydrogen bond with water is nitrogen, oxygen, and fluorine.
But is there chemicals on that form?
It's not a chemical bond. It's going to be an intermolecular or interparticle bond that basically the water surrounds it and kind of like surrounds the ion. Yeah. It's called hydrated because now that substance is wet, if you will. Yeah, because it's surrounded by water molecules. All right, so I need to balance this. So how would I do that? I need 3 here, and I need 3 here. Am I balanced now? Yes, I am. Okay? Now let's do calcium acetate plus sodium carbonate. How do I write calcium acetate? Two acetates. And then how do I write sodium carbonate? And y'all have got the formulas down. Good job. Okay. Outside, inside. Here we go. You do not have to draw the arrows or the lines. I just do it to show you guys. It's not a bad idea to do it, but you don't have to. What are we doing first this time? Outside or inside? Outside. Are we? All right. How do I write calcium carbonate? Just CaCO3. Plus, how do I write sodium acetate? No, not Na2. So it's 1-to-1. Goes together 1-to-1. Okay. So sodium, right off the bat, when we see sodium, what do we say to ourselves? Aqueous. It's a group 1 metal. Also acetates, also always aqueous. Okay. So as soon as we see a group 1 metal, you should immediately write down aqueous underneath it. You don't even have to think about that. So group 1 metal, aqueous. Someone asked me this last period. Let me ask you guys, is hydrogen a group 1 metal? No. A, it's not a metal. Yeah. All right. I need to balance it. What do I need to do? Put a 2 in front of acetate. And does that take care of everything? Yes, it does. Okay. This next one is a special like subset of double replacement. Okay. It's an acid and a base. Okay. So this is the acid. How did I know that? Because it says acid. A base, for our purposes, we're just going to be looking at hydroxides. Hydroxides are bases. So anytime I have an acid plus a base or a base plus an acid, I am going to produce a salt plus liquid water. And liquid water is a pure substance, so this reaction happens because I will always produce salt plus water. And water is liquid, it's not aqueous. Okay? So because I'm producing that, this reaction is going to happen. Now, I want to caution you, when we say salt, do I mean NaCl?
Not necessarily.
No, I absolutely don't need it here. I have no chlorine nor sodium anywhere to be found, so there's no way I can make NaCl. But I can't tell you how many times people will do that. They'll be like, no sodium and chloride on the reactant side, and then they'll write down NaCl plus water. No, salts are a class of compounds. It's the anion from the acid and the cation from the base, and they make a salt. Okay? So, calcium hydroxide, how do I write that? Okay, and phosphoric acid.
H2PO.
Not 2, H3PO4. All right, outside, inside. Let's do the outside first. How do I put calcium and phosphate together? And then what am I going to make? H2O. And that is liquid water. So I know that this reaction is going to happen. But let's go check our what phase we should put behind calcium phosphate. So go to your solubility rules. Find phosphate. It is insoluble solid, so I'm going to put an S behind there. Okay. Most of your acid-base reactions will actually make something aqueous plus liquid water, and we'll do an example of that in a second. But sometimes it can also be a solid. And the only time that I take off for phases of matter on the test is for the double replacements. You must list that, because that's how we can tell if a reaction happened or not. Okay? All right, let's balance this baby. What do you notice first? The calcium. So let's fix calcium. We need a 3. What do you notice next? We do need 6 hydroxides, but I don't have hydroxide on the other side. I do have to put it for H2O, but before we do that, let's look at something that's going to trip us up a little. The phosphate. I've got 2 on the product side, so I need to put 2 right here. Okay. Now, how many total hydrogen do I have on the reactant side? 12. So the only way I can fix that is to do what? Put a 6 in front of water, and what did that just do to my oxygen issue? It balanced it. It's like magic, only it's real, it's science. Okay? I would like to do a few more examples. I don't have to. If you want to start working, would you like me to do some more examples?
Yes.
I figured you'd say that. Does everybody have this before I erase? All right. These examples are not in your packet. Oh, sad. Well, I need you to practice something. Okay. Let's do silver nitrate plus sodium chloride. Silver nitrate. By now, you shouldn't even have to think about that. How do we write silver nitrate? AgNO3. We are getting to be experts at that one. And sodium chloride plus NaCl. Outside, inside. What do you want to do first? Outside or the inside? Outside. How do I write silver and chlorine together? AgCl plus sodium and nitrate. And we wrote down sodium and we wrote down nitrate. Do we even need to check the solubility rules? No, they're always aqueous. Every day, twice on Sunday. How about, what does it say about chlorides? They're soluble unless with a silver, mercury, and lead. Bingo, we have silver, so it's an insoluble solid. Do I need to balance this? Nope, everything's 1 to 1. Happy dance time. Easy peasy, lemon squeezy. All right. How about let's do some sodium carbonate. How would I write that? Na2CO3. And let's add to that some iron 3 chloride. FeCl3. All right, outside, inside. We've been doing outside first. Let's be different. Let's do the inside this time. Because it doesn't matter what order we put it in, does it? It does not. Okay? So how would I write iron 3 carbonate? Y'all got this down. Okay? Plus, what does that leave me? NaCl. Well, got sodium, so what do I immediately write behind that? Group 1 metal, always aqueous. Now let's go check our carbonates. What does it say about carbonates?
They're insoluble.
They're insoluble unless they're with one of those exceptions. Iron is not one of the exceptions, so insoluble solid. So because this happens, we need to balance it. What's the best way to balance this? I need to put 2 right here, right? Okay. Excuse me, how many chlorine does that give me now? 6, so let's put a 6 there. How many sodium does that give me now? 6, so I need to put a 3 right there, and then what did that just do for our carbonate problem? Balanced it for us. Yeah. Big brain, that's right. All right, let's do one more acid base. Acid base, let's do sulfuric acid. How do we write that? H2SO4 plus, let's do potassium hydroxide. Well, I know how to write it. Y'all tell me. It's like all of a sudden y'all forgot that yeah. Okay, outside, inside. Let's do the inside first. How do I write potassium sulfate? Ooh, K. What is K? Group 1 metal? Aqueous. And then that leaves me to make H2O, which is a liquid. So this definitely happens. So we need to balance. Well, the first thing we notice is the 2K. So that takes care of that. Now, how many total hydrogen do I have here? 4, so I need to put a 2 right there. Does that take care of everything? There we go, done. Okay, I didn't show you any that make a gas, but if you do make a gas, it also happens. Solid, liquid, or gas means the reaction happens. If everything is aqueous on the product side, it's a NER. Okay? Yes?
How do we know if something's going to be a gas or a solid?
The solid, you'll check the solubility rules. That's how you know a solid. For gas, it's going to be something obvious like it makes CO2 or it, you know, that's going to be obvious.
Or just hydrogen?
Well, for double replacement, it won't be making hydrogen. It's usually going to make something like CO2 or SO2. They don't come up that often, but they do come up occasionally. Okay? All right, any questions before I stop the lesson? All right.